Okay, this video is our first in-class practice for exponential functions. And today we are talking about how to actually use exponential functions to discuss real-world situations. I don't want to say problems, but situations. So here's our first one. I just want to remind you that we are going to be using during this, and I know you've watched the notes already to go with this, but we're going to be using y equals ab to the x to complete these. And the other thing I want to tell you is sometimes you're going to get used to writing y equals ab to the t because a lot of time our independent variable is time. And I want you to remember that a is your initial value. And that is also your y-intercept. And then your b is your growth factor, is what we call it. And your rate is inside your growth factor. It's 1 plus your rate if it's actually growing. And it's 1 minus your rate if it's decaying or decreasing. That's just a little quick recap. And so let's start with this can of soda. So I have a typical can of soda. It contains 150 milligrams of caffeine, and every hour, approximately 15% of the amount of caffeine in the body is metabolized and eliminated. So I'm going to kind of go through here and actually kind of underline what's important. Well, first of all, if I didn't know this was an exponential practice, I would see this 15% is eliminated every hour. So that's, remember I told you if you saw percent per anything, well, this is percent every hour. I can tell it's exponential. The other part is that it's metabolized and eliminated. So that means it's decreasing in your body, the caffeine after you have your soda. Okay. The next thing it says is I started with 150 milligrams of caffeine in that soda, and it's decreasing every hour. That's all good information to know. So I'm going to find a formula. Now, I don't care if you use y equals ab to the x to do that, but when you're done, you need to make sure that you use the letters they want you to. And in this case, they want you to use caffeine is c and the time is t. All right, so I'm going to do y equals ab to the x. And I know my initial value of caffeine is 150 milligrams, so that's going to go here. And then my growth factor, as I do this, I say, okay, my growth factor is actually decreasing. So how's it decreasing? Well, it's 15% per hour. So I'm going to do 1 minus my rate, 1 minus 0.15, which equals 0.85. So that's what's going to go here. And I want you to recall that if your growth factor is between 0 and 1, then it's a decaying or decreasing function. So now I'm going to write it how they want us to write it. They want us to say C for caffeine equals 150.85 to the T. And then the other thing I want you to remember is I always have you, I didn't mean to do that, I always have you guys label the crap out of everything because I'm going to give you so many variables this year. So I'm going to make sure that this is caffeine in milligrams, and I label it, and this is time in hours. That's important that you know that. The other thing is if I had a point, the point would be TC. So this is hours, and this is my caffeine in milligrams. And if I was going to graph it even, I would have on my x-axis, and remember life is in quadrant 1, the time would be here in hours and the caffeine would be here. So I kind of do that every time just to make sure I'm comfortable with what's going on. Now, first of all, it says how much caffeine is in the body after 3 hours, after 10 hours. So during class time, we actually started graphing the function here. So I want you guys to, I'm going to kind of go through this before I'm going to set this up before I actually go through it. So basically, if it's 3 hours and 10 hours, now that I've labeled it, I know it's going to go in the T spot. So I'm going to do C equals 150.85 to the 3. And then I'm going to do C equals 150.85 to the 10. And I talked to everybody in class, and I go, I do know for sure that my numbers will be decreasing each time to do that. So we actually graphed it in class. So I'm going to bring up my graph. And first of all, we have to fix our window. So you know that your initial value is 150. I know I had to go from 0 to 150 at least to see where it crossed. And then where it hit the y-axis. Then it's decreasing and decreasing, and it never really hits the x-axis. But when you do this, you're going to plug it in, and you're not going to see it at first. So you're going to hit Menu, you're going to hit your Windows Zoom, and then you're going to look at your window settings. And I want you to notice that I have my x-min and y y-min in 0 because that's life is in quadrant 1. I made my x max 35, and I'm going to show you why I did that in a minute. And my y max is pretty easy because I know it's 150. But everybody always asks me, well, how do you know that that's 35? Well, I don't. Later on, I'm going to find out how long it takes for 1 milligram to be left. So what I actually do is Control T right here, and I look at my table, and I see that at 0, it's 150 milligrams, and every hour it's going down. And I know the last part is I'm going to ask, okay, when is there 1 milligram left? And the only reason why I knew to go way over to at least 35 is because between, looks like hours 30 and 31, it's going to be 1. Now I am going to show you where we can be more specific, but that's one of the things. And the other thing is I actually showed them to graph it right off the bat and bring up your table because I just asked you for the third hour what's left. You can just write this down instead of plugging each one in. And I asked you in how many hours? 10 hours, and that's how much is left. So it's decreasing right along. So you can actually take that and copy that down. So I know this is 92.12 milligrams is remaining in the body after that. And after 10 hours, according to this formula, it's 29.53 milligrams left in the body. Okay. Now, here is where I kind of set myself up as to answer this question here, because it says, how long will it take for all the caffeine to be gone? Well, you do know from our notes and everything that if it's exponential, as you keep taking a percentage of something, you're never really ever going to hit 0 or the x-axis. So instead of saying 0, because that won't work, we're going to do 1 milligram, which is essentially gone. So the 1 doesn't go in the time spot. The 1's going to go in the caffeine spot. So I want you to write the formula as 1 equals 150.85 to the t, because you're asking how long. So you're solving for time. Like, how long does it take for all of it to be gone? So here I start at 150. I'm going down to 1. I want to know how long that's going to take. Now, because a t is an exponent, in order for you to solve this, we would be using logarithms. But because we haven't done that yet, I do not want you to use logs as of yet. So what I want you to do is kind of set this up for the answer. And then we're going to actually do a nice sketch of that graph I just did. So this is time in hours. And this is caffeine in milligrams. And since this is my sketch, I know 150 is here, and it's going to come all the way down like this as my sketch. And then I want to know when there's 1 left. So if I graph that, find out where they cross, I can find out how long that takes. So basically what we're doing is graphing this right side and then graphing this left side and see where they intersect to find out what the answer would be. Okay, so I want you to do it this way. So I'm going to go to my calculator. I'm going to get rid of the table right now. And I already did it, but if you do Control G or arrow up, and if you want to look at it, you're going to graph 1. So when you hit enter, I have this little, mine's red, but I have this red line, and I want to see where it crosses. Well, the answer's there already, but I'm going to show you how I did it. You hit menu, you're going to analyze your graph, and you're looking for the intersection. When you do this, you're going to use your mouse and kind of come to the left of where you think the intersection is and to the right. Now, the one thing I do want to tell you, so it's there twice because I've already done this. Okay, so I'm going to get rid of one of them so it's not bothering us. But I also want to warn you that your intersection has to be within the window for it to do it. So if I didn't go over far enough, you could tell, so I'd have to keep moving over to do that. So it shows in 30.8 hours, which we already knew was between 30 and 31 hours, but that's much more specific. So I'm going to say it took 30.8 hours for that caffeine to be eliminated and gone out of the body. Okay. Now, our next one, we don't need to graph, but it talks about the annual inflation rate is 3.5% per year. So right off the bat, I got all excited because it's percent per, so I know it's exponential. And inflation, you need to know inflation is where it goes up. So I know this is an increasing exponential function. And we're talking about a movie ticket. So they said if a movie ticket costs $9.50, find the formula P, the price of the ticket T years from today, assuming that movie tickets keep up with inflation. So if we use y equals a b to the x, we do know that my initial value is $9.50. You don't need the zero, but we're going to do that because it makes me happy. And if it's increasing, I know this is 1 plus my rate. So you're going to change that to a decimal to 1 plus 0.035. So now I have 1.035 raised to the x. Now, because they want me to use P's and T's, I'm going to replace that because that's important that you do what they want. So I know my price of my ticket is going to be initially starting at $9.50, and it's growing 3.5%. And this is per year. So we're going to label everything out. This is the price of the ticket. Label the crap out of it in dollars. And this is time in years. Okay. Now they said, according to your formula, how much will movie tickets cost in 20 years? So what we're going to do is just plug a 20 right in the T spot. So I've got P equals 9.50. 1.035 raised to the 20. And a lot of people say, Mrs. Pond, how come you don't really tell us how to round? Well, especially on this one, I don't need to because it's money. So you can only go 2 decimal places for cents. So this comes out to be 1890 according to this formula in 20 years. Okay, so that's the second place we're going to use it. So now I'm going to clear the ink from this page so it doesn't get so messy. And let's do number 3. So the last in-class practice today, we're talking about the amount in milligrams of a drug in the body T hours after taking a pill is given by A of T equals 25.85 to the T. First thing I want you to do is label the crap out of it. So this is the amount of the drug, and make sure you do your units, which is in milligrams. Okay? And then the time in this case is going to be in hours. So this shows what's going on. So let's kind of answer the questions with this. So what is the initial dose given? Oh, that's easy. Right here's my A. So I have 25 milligrams. I'm using Christmas colors. So I have 25 milligrams. And make sure you use your units. It's very important that you do that. Okay. What percent leaves the body each hour? Well, because it's, decaying in your system or your body is metabolizing it, I know it's decreasing. Now, I know it's the same that I had above, but basically, this is what I want you to show me. This shows that 85% is left in the body after each hour. So you're going to do 1 minus your rate, which is 1 minus 0.85, which is 0.15. Move your decimal place. So that means 15% leaves the body every hour or per hour. Okay? So that's all you need to do for that. Just make sure you show me that work. Now they want to know how much is left in the body after 10 hours, and then we're going to talk about the 1 milligram again. Let's be smart and let's graph it right now. So I did, okay? And I had to fix the window, and I had to go at least from 0 to 25 because that's my initial value. And I actually went over to 20, and you'll see why, because I looked at my table again, and so you want it to fit the window. So if you hit Control T, you're going to be able to look at your table and answer any questions because they wanted to know in 10 hours. So if you come all the way down to 10 hours, there's 4.92 milligrams. So just make sure that you show me your equation. So I'm going to do A of 10 equals 25.85 raised to the 10 because that's where it's going to go. And then I'm just going to actually go in my table and say, okay, that's 4.9 milligrams. Okay. I usually say 4.9 what? Toenails, and everybody cringes. So make sure you label because that is gross. Okay. Now, the last thing we're going to do is how many hours is there less than 1 milligram? So we're going to actually put it equal to 1 milligram because I can't go to 0. Remember, it's exponential. So I've got 1 equals 25.85 to the T. Okay. And then I'm going to go like this and set it up for the answer. You do not need to use logs because we haven't done that yet. Now I want you to draw your graph because you kind of know what it's going to look like already. Make sure you label everything. So this is my time. Let me go down a little bit more. Time in hours. and here's my amount in milligrams. And since it's my sketch, 25 is going to be right here. Now it's going to be decreasing. Okay. And then I want to know, hey, when is there 1 milligram left in the body? So we're going to graph that and see where their intersection is. That is exactly how I want you to do this on the quiz. That's your picture. And I use Christmas colors for you, so enjoy. So let's go back to our calculator. I'm going to get rid of my table. And I did look, so I went over to 20 here so I could see the intersection. I graphed y equals 1. Okay, so this is very similar. Hit your menu, analyze your graph, find your intersection. Go ahead and do this. Go over to here and do this. I'm going to do it again, I guess, because I already had it once, but it doesn't show. No intersection found. Well, that's silly. So let's move this over. Maybe I didn't do it right. Let's try that again. Menu, analyze graph. Maybe I didn't go over far enough because I do believe it intersects in here. Let me see if I did it right. We'll hit it here and come all the way here. Okay, I'm going to go over farther. So isn't this fun when this happens on a video? So I'm going to go to my Windows Zoom, my Windows settings. I'm going to change this. I'm going to delete, and I'm going to go to 25. Just to, oops, not 5, but 25. So I'm going to hit enter. And there's my intersection. It is now showing, but I want to know what that is. So I'm going to hit menu, analyze graph, look at my intersection, come on over here. There's my intersection. There we go. It took 19.8 hours. Must be I was too close to the edge. So that's all you do is come back here and you just tell me 19.8 hours it takes for 1 milligram to be left, and you're good. So that concludes this video. So I hope it helped.